All right, everyone. We'll kind of slowly start. We'll we'll be getting started in a minute. And before we start the official part, everybody from backstairs, come over. And before we start, first of all, I just wanted to welcome you all in, say that I'm super grateful to see you all and see the new faces, especially. And the old faces. Thank you all for coming to SFRuby. Yeah, let me say a few words just before Cameron takes the mic and kicks this off. So we are something that I've been super busy doing the last month or so is something that was born out of this meetup, and this is the San Francisco Ruby Conference. Yeah, thank you. So this is the sfruby.com, the conference that we are running in November in beautiful Fort Mason, beautiful marina, with the goal of having around 600 Rubyists get together around Ruby for startups. This is what we want to focus on this time and with this conference. Thank you. Yeah, I'm really not a great user of these mics. Thank you, Cameron. All right, so SFRuby conference. This is something where we are gathering 600 Rubyists, and we already have the full schedule. I'll show you this in a second. But what we are focusing on is these topics. So the new open source, and tooling that is targeting startups, targeting very ambitious companies building new products with Ruby. We also have stories from companies that already scaled on Ruby, and they're gonna talk about solving lots of kind of scaling issues, scaling problems. We'll have the CTO panel. We have the CTOs of, the rule is if you grew a company on Ruby to above $10 billion, then you can participate. So we have the CTO of Gusto, Chime, and Clio. You'll hear from them. And finally, we have something completely new, which is Ruby startup demos. So startups that are building, I want to show you this in a second. Startups that are building with Ruby, building new and exciting products, they are going to do 10-minute demos. The purpose is to inspire us all, for all of us to really connect with those companies, to really learn what people are building. A bunch of this actually are YC startups. You might know Boltney, which is popular. So they are just incredible. I just want to tell you to kind of maybe click those links, check out them already. They are like incredibly exciting. I remember this one is one of the startups that are kind of coming from this meetup. So the person working there, Shrey, he attends the meetup, and Superconductor found. So a bunch of founders are here. Maybe we'll hear from Superconductor, by the way, today. So these are the startups. Let me go into speakers for a sec. So actually this is a new page that I was working on. Again, not a front-end developer, really. But yeah, we have this page, the full schedule. We probably will still shuffle something, but there are a few talks that are to be TBD. But basically, you can already check out the schedule and check out the workshops. So we'll have Inertia Rails workshop. We'll have building agents with Rails workshop on Active Agent. We'll have another workshop on upskilling by diving into Rails internals from Casper. And there is a workshop from Noel, and it's going to be about Ruby type system. So I encourage you all to grab a ticket and register for the workshops, because workshops have limited capacity, just 48 people, and the earlier you register, the higher the chance that you will get into your workshop of choice. That's that. And finally, a huge shout out to our sponsors, including Temporal, that will have a talk from them today. So let me just, that's all I want to say. Hope you guys enjoy the meetup and will join us at the conference. If you have any questions, please reach out. Let me know. And with that, I think we can get started with the meetup. Okay, folks, any questions? What do you think? Okay. Cameron, take it away.
Hello and welcome to our SF Ruby meetup for August. Thanks all for being here. Also, big thanks to Github for hosting us for, I think, the third time. Thank you, Github. Also, big thanks to Irina for putting together not only this meetup, but also, as you saw, all of her work on the SF Ruby conference. She's not doing that single-handedly, but I have a front row seat to a lot of the communication that's happening. And I can tell you that she's doing a great job and with a small team. So thank you so much, Irina, for putting that together, for getting us all together, and for re-energizing Ruby in the Bay Area. It's awesome. Okay, our first speaker today is going to be Drew Hoskins from Temporal. Drew is trying to connect to the Wi-Fi, and so let's all watch him do that. Just kidding. Yeah, so he'll talk to you about what Temporal is. We've actually been trying to get Drew to come and speak for a long time, and so I'm really excited that he's here today. Are we all connected? Okay, Drew's a project manager at Temporal, ex-Ruby engineer, and take it away, Drew.
Hey everyone, I'm Drew, product manager at Temporal. I do developer experience stuff, and I care a lot about developers since having been one. I am currently focused on infrastructure for AI agents. Temporal's being used a lot for that stuff, and so it's a very exciting time for us and for me, and also a lovely community. As I said, I was a Ruby engineer at Stripe, actually. I built this framework called the Workflow Engine, or I founded the framework. We were using Temporal under the hood, and it's now used at Stripe by hundreds of teams to just do software. And you'll learn more about what Temporal is tonight. Who here has heard of Temporal? Okay, pretty like 20% maybe. So we used a framework that was developed by Coinbase originally. I was actually, it looks like I'm the fourth contributor to this thing, really bootstrapping the Temporal community for Ruby. It wasn't a sanctioned SDK, it was a community-built SDK. And I'm here tonight to tell you not to use that thing. Use the new Temporal sanctioned Ruby SDK, which has come out this year. Very excited. It's more scalable and efficient than the one that we worked on, and yeah, very, very excited to finally get some official Ruby love. I am also an author, so I don't know why this is low on my screen. Let me try to correct this. Okay, cool. I'm an author, and I am writing a book called The Product-Minded Engineer. It's out with O'Reilly this December, so take a look for that. It's the goal, as my career has gone on, I've become more user-centric than I was early. learning more about users, empathizing, thinking about their scenarios. And so I want to distill that wisdom and help other people along their similar journeys. So yeah, I'm really excited about that, and I've got to finish it this weekend. So why am I here? I don't know. Okay, so today we're going to talk a little bit about like high level why temporal exists, why durable execution exists, introduce what durable execution is. I'm curious if anybody here has heard the term durable execution. Okay, a smaller percentage of people, but non-zero. Okay, so we'll talk about that. And yeah, show a temporal application, see it in action with a demo, of course, and we will actually try to have our demo fail, unlike most demos. At Temporal, we love demos that go awry, because then we can step in and show why Temporal is cool. Okay, so modern applications, they are distributed systems, typically. As you think about software, the trends are we're doing more and more sophisticated things with web software. So they're getting more asynchronous, more steps to complete them, more autonomy with AI. And so basically, as time goes on, people's demands for software increase. That means that you're orchestrating more things to achieve what the user's demanding. And AI has supercharged that. And so to build a distributed system application, we split our application across services. Those services connect via the network, and then we have to, of course, scale that and make sure it has however many nines of reliability we're going for. So shout at me. What are some things that go wrong with distributed applications? Network failures. Timeouts. Hotspots and loading problems, yep. Out of order messages. Split brain, yep. Great, good examples. And so many of those are things that Temporal is designed to, or durable execution in general is designed to help you with. And so APIs could go down, a database could go offline, a queue could back up, thundering herd problems, network calls, somebody said timeout mysteriously, and then you don't know whether the thing at the other end of the network call succeeded or not. There's also a bunch of sort of application layer challenges that you have to deal with when writing a distributed apps. So like state tracking, where are we in this application, what's been done so far, and what has to be done. Making sure my operations are idempotent so that if I'm moving money and I call that moving money function the second time, I don't want to actually double move the money. I want just the one, the movement. So applications are getting longer running, and so I have to manage those. And if a process crashes, make sure that the application can recover. So lots of things to do. And the problem is actually like without tools, the problem just like gets worse over time, right? Because the complexity is increasing. And so, we become less productive and less focused. And we start spending more of our time on what we call undifferentiated heavy lifting, which is basically solving problems that thousands of or millions of developers have already solved elsewhere, but like for your specific problem. And then when something does go wrong, because your application is complex, pinpointing exactly like which stage of this 4-stage pipeline failed is often a big challenge. And this was actually the reason why I wanted to build the workflow engine at Stripe, was because like I couldn't debug things in our event-driven system. It was painful. So yeah, we have a bunch of low-level tools, load balancers, batch processing, events and queues, error handling, try-catch blocks, rescue blocks or whatever. But we need something more holistic than those low-level primitives. And so durable execution is really an attempt to be that more holistic solution to these problems. And the core piece, the core tenet, the core like sort of value proposition of durable execution is that your code is crash-proof. It's resilient when things go wrong. And the way it achieves that is that it maintains state of your application as you go. So it's basically like journaling everything that you're doing, everything important that you're doing. And so that you can, if something goes wrong, you have a record of what happened so far, and you can kind of resume from where you left off. And I'll get into the details and show how that works as we go forward. And then, the result is that your application can continue executing despite all the chaos that people mentioned can happen. And in turn, this makes it just much more productive to support these applications. Durable execution is a concept that was pioneered by the founders of Temporal, actually when they're at AWS, and they built AWS step functions. And then they moved on to Cadence at Uber, and then it became Temporal and got open sourced. But there's now a bunch of other durable execution frameworks like Restate, DBOS, Ingest, and so forth. So it's a thing, although a relatively new one. So Temporal is a popular open source durable execution platform, and it reduces your code's complexity and helps you build out reliable applications. It's MIT licensed, so there's no really catch to it. I'll talk a little bit about the business model at the end. Okay, so some of the things that Temporal does for you is it handles retries for you, so it automatically retries things. It has queues. It tracks state implicitly for you, so you don't have to create these state objects that sort of track where your process is. That's just sort of like part of coding in Temporal, is that you get state tracking automatically. It has timers. I'll show that later. Temporal is designed to be a very code-first framework. So you don't have to build a graph. You don't have to have a DSL. It's just Ruby code. And we put a lot of love into our SDKs. And so the goal is really be idiomatic, be whatever in the code in the style that the people of that language are used to. And then you can run your code wherever you would normally run your code. And so it's really supposed to be very, very developer friendly. And the thing it provides is that like durability layer to make sure that your orchestration is successful across all the network conditions and database conditions and everything else. Okay, so what is a Temporal application? It starts with a workflow. The workflow is really an embodiment of your application. And workflows orchestrate using these steps called activities. Activities, and I'll show that later. So activities like a database read or a network call or something like that. And then all of this gets executed on workers. Workers are just, if you're running in the cloud, worker is basically a service, right? And if you're running on your laptop, as I will do later, it's a script that is running in the background. Okay, and then there's the Temporal service itself, which is a kind of an API gateway meets task queue manager. So the task queues are the things that your tasks are going to run on, and then a database to like keep track of everything that's happening. And Temporal kind of bundles all that together into a beautiful product. Okay, so what do workflows do? So workflows, like I said earlier, they handle state tracking for you so that when you have a crash. They are also interactive. So if I'm building a chatbot workflow, for example, like users can type into the chat window and send signals to the workflow with new information, and the workflow can respond to those messages. And then they can run forever, so they can run a long time. And yeah, they're certainly beyond the scope of a single process. They can persist. And then I mentioned activities, the individual steps, and we'll see this in a minute. So a typical activity would call a remote service, so an API call. It would process files. It would send an email right to a database. Really just activities are code. They do things. There's nothing that's super special about them, as you will see. Okay, and then workflows interact with activities by orchestrating them and persisting the results of those activities so that they don't have to retry. I'll show you that. And then, yeah, the workflows retry it by default. So when you call a function in a workflow that's an activity, you get a retry policy for free. And so it's handling a lot of the stuff that you would normally have to code by hand. And like I said earlier, temporal will resume when from where if your application fails at any point, the workflow will resume from where it left off. Okay, and then workers, I think, pretty straightforward. They execute the workflows and activities. You run them yourself, and so like you don't have to like upload your code to anybody or anything like that. They're just really like any other application. They pull rather than push, so they're a little bit different, but mostly just normal services. Okay, and then temporal service is sort of the cardiovascular system of your application. It's the beating heart and the thing that keeps everything running. Task queues I mentioned earlier, that's the thing that's like any activity or workflow that's about to execute is going to run on a task queue. And then how does this durable execution work? The key concept underlying the durable execution is called an event history, and that's basically a journal of like, hey, I called this activity, and then I called this activity, and then I received this signal, and so forth. And that's all kept track of in the event history, and that's the magic. And so if you've heard the term event sourcing, temporal is sort of under the hood an event-sourced framework. Okay, so I bet some people are waiting for code. So we're going to do hello world, of course. And it's going to be, you'll see it, it's a web application. And what it's going to do is it's going to make 2 HTTP requests in a row. The first one is going to get my IP address, or the IP address of the user who's calling our application. And then it's going to use that IP address to fetch the geolocation. And so not something you would normally want to make durable, but like just go with it. Like imagine instead of hello world, it's moving money or sending emails or something a little more important, and just suspend disbelief because we've totally over-engineered this particular application. But it's hello world, we have to do it. So, okay. So yeah, so the way that this will decompose is we'll build an activity for each of the 2 functions that I mentioned. Those will get orchestrated via a workflow, and I'll show you that. And then I'll spin up a worker to sort of execute it. And then there'll be a UI. So, okay, here's an activity. There's really very little special about this. It's just a wrapper around a function. But this function has a couple superpowers that make it distributed systems friendly. So first of all, it runs on a task queue, right? And so I can buffer the execution of it. Secondly, it has a retry policy and it has a timeout. So basically the basics of what you need to run a function in a distributed system, that's an activity. Here's another activity, it does another fetch. And then let's execute that. So here's a workflow that calls those 2 activities in a row. And just a couple interesting things here. First of all, this execute activity, the results of it are going to get memoized under the hood, so you don't have to deal with that. There is a default retry policy given to each activity. I've actually I've customized the retry policy on this one just to show, also because the retry policies by default exponentially back off, so they try after 1 second, 2, 4, 8, and so forth. I don't want it to get too long for the demo, so I just like capped it at like 10 seconds. But normally it'd be like more like 10 minutes or half an hour or whatever. And yeah, so activities are just going to retry until they work. And so if there's, workflows are they want to succeed real bad. They keep trying by default. Okay, and then here's an example of a worker. We provide the worker for you, and you really just configure it. Like here, we're configuring the task queue name and then the list of workflows and activities that this worker can execute. And so when you see me run the worker later, this is sort of the code. And then when you create a workflow, you do some boilerplate code. One interesting feature of workflows is that they have IDs. They have an ID and so if I create a workflow and then I retry to create that workflow, or some other client recreates that workflow, it's deduplicated. So you can get exactly once kind of creation of workflows using these deduplication keys, which comes in very handy. Okay, let's do the demo. See if I can do this with one hand on my microphone. Okay, so let's start Temporal server. This is like a SQLite version of Temporal server that's running locally. Temporal in production will run on Postgres or Cassandra or MySQL or other things. Okay, and then I'm going to run my worker to run my workflows and activities. Is that big enough? Let me increase that. And then I'm going to run this app, which is just like a Ruby web app. Okay. So we've got our stuff running, and 1 second. Okay. Okay, someone give me their name. Rhiannon, awesome. Okay. Hello, Rhiannon, your IP address is blah, and you're in SF. Okay, lovely. So let's see what this over-engineered hello world did behind the scenes. Okay, so we can see here, this is Temporal's user interface, and this is the list of workflows. This list will grow as the night goes on. And I can see here a timeline of everything that happened. And so timeline from the left, and then it ran get IP activity, which got the IP address, and then fed that into a location. And it showed me how long it took each one to execute. And so it all finished in 240 milliseconds. And then I can also see a sort of more textual representation of the same thing below. Okay, so that is the happy path. Now I want to show you timers. So let's add a 5-second sleep here and see what happens. So what I've done is okay, so now we got a response back after 5 seconds. So I'll show you two angles on this. One, I'll show you what the UI shows us, and then I'll show you the code. So here's the UI. This orange blob is the 5-second timer. And then once that timer finished, we did our normal thing. And now let me show you the code. Okay, so at the beginning of my workflow, I just slept for 5 seconds, basically. And it's as simple as that. That sleep could be a week. So let's say I'm doing an email marketing campaign, and I send an email, and then I want to nag my user after 7 days. I just sleep for 7 days, and then it wakes up, and I continue. It kind of feels like coding as an undergrad again, like when I code a workflow. It's kind of cool, because I don't have to deal with a lot of stuff that I used to deal with. Okay, so that's timers. And now what I'm going to do is like cause some havoc. So let's do Rhiannon again. Okay. And let's do a 10-second sleep. Okay, and now I want to show Temporal being resilient to bad things that happen. So the first bad thing that happened is I'm going to kill the worker. And now let's see what happens. So now I can see this running workflow. And if I click in, I see this timer, and it went 10 seconds. And then nothing's happening, because there's no worker to run the workflow. But as soon as I restart the worker, which is, you think your service went down, or you did a deploy or something, then it immediately starts executing again and finishes. So that's pretty cool. Let's do it again, but this time I'm going to crash the server. Okay, so now Temporal's gone, Now I can't go and like debug it because Temporal's gone, so like the UI is not going to work. So it's like 0 workflows because there's no Temporal server. So that's not good. But notice I have this DB file name demo.db here. That's the database that's persisting all of those event histories that I talked about. And so if I restart the server based on that same database now, it's going to come back up. And then it will complete. Yeah, so it's already completed here. Cool. Okay, one last piece of havoc. I'm going to imagine, and this one you probably haven't seen before. This is the funnest one. So let's say you have written a bug. And so I'm going to misspell HTTP. And then I'm going to redeploy my worker. Redeploy meaning I'm just going to restart the worker to get the new code. And then I will try to run a workflow. And let's do Ziggy this time. Ziggy is our mascot. He's a tardigrade. It's a tardigrade. They are a tardigrade. Okay, so let's see what happens. Okay, so I've got this running workflow. And something's wrong. I see this red bar. So what are we seeing here? So it says attempt 6 out of infinity. And so it's just doing its retry policy. It's like there's this bug. And so if I click in, I see a couple things. I see a failure message, so I can debug. I can see a stack trace. And I see some more facts about this activity. So I can see its retry policy. And so I said, basically, I've got an exponential backoff retry policy, so doubling the backoff interval. I've capped it at 15 seconds for demo purposes. And then, imagine that your application fails, and instead of having to like spend hours figuring out exactly where in the pipeline it failed, with Temporal UI, I just literally pinpoint exactly what failed almost instantly. And so here I have a stack trace. The stack trace is telling me where to go. So I go to that line and I fix it. And then I redeploy my worker. And so normally you might think this kind of failure is like not a retryable failure, right? Like there was a code bug, it's not going to work, just end and then go fix it and then try to recover manually later. But with Temporal, basically every exception is a retryable exception because even a code bug can be fixed and then you redeploy and now the worker is going to resume from where you left off. And so we can see it's already completed, and I didn't redo get IP activity. That was memoized and set in stone, and I just resumed from where I left off. And so no manual recoveries, no like having to go and like update the database that didn't get the write to make it eventually consistent with the one that did. Like you just literally just deploy the new code and it fixes itself. Yeah. So hopefully that's enough mayhem. I don't think we have time for a simulated network failure, but that's the one that we would do if we had time. But I would just like turn off Wi-Fi and then show it that. But I think you all get the idea. So. Okay, so what does taking Temporal to production look like? So you have two basic options when you start using it in earnest. You can use the open source self-hosted version. It's MIT licensed, and that scales pretty far, actually. You can use Helm charts to deploy Temporal server on your on-prem. Or you can use Temporal Cloud, which is the way that we make money. You can actually migrate apps back and forth between the two. All the same features are available in both. Temporal Cloud is managed by experts. It has more scalability, and it has a better persistence layer with like lower latency and other perks. And so but like as far as the applications that you can run, like you're not locked in to either way. And they're both good options used by many, many people. Temporal is used by, you've definitely used it without knowing it. If you've used the internet in the last decade, well, 5 years, I guess, more like. I think Temporal was founded in 2019. And what to say here? I think OpenAI's, well, so I know that OpenAI's ChatGPT images and codecs were built on Temporal. In fact, I believe ChatGPT images was the fastest scaling consumer product ever or something in terms of adoption. So Temporal held up under intense pressure in that launch. And so, yeah, lots of people using it. And yeah, please join the community. We have an awesome community Slack. Oh, there's Ziggy. I didn't know he was going to appear. They were going to appear, but that's Ziggy the tardigrade. And we sent Ziggy to space as a publicity stunt at some point, or like near space. It was cool. So yeah, Ziggy's very resilient. Anyway, yeah, that's Temporal. That's dual execution. Question?
Questions?
What's the TLDR between Temporal and Redis workers with decent retry logic on your side?
I don't know anything about Redis workers. Sorry. Yeah.
Those were great demos. I imagine in the case of bugs, oftentimes you end up in kind of a garbage in, garbage out situation where because of the bug, like other things did run and you now kind of want to like roll it back or say, go from here forward. I'm kind of curious if there's stuff like that in Temporal, because the idea that it just picks up where it left off is cool in the demo you showed, but I can imagine it could be like running amok in a way that's not good if you actually had introduced some corruption, you know what I mean, in the process.
Yeah, so you can, so we don't see the running amok causing problems so much, but there's definitely cases where you need to rewind a step or to the beginning. And Temporal has a functionality called reset, which does that. It's not something you want to be using, but it can get you to those points where it's like, oh, that last step had a bad output, which then caused the next step to fail, but really the bug was one step earlier. And yeah, so you can reset.
Yeah, nice demo. I have a question about the events, how long they stay, and in case of multi-node systems, if the node goes down, what happens to the events? Those were sent to that node. I'm assuming the event database is decentralized. It's not in the one place.
So, okay, so events go into the database, and the database is replicated, and so it's data loss on events is very rare.
It's distributed.
Yeah.
It's not replicated, but the workload is split.
Mm-hmm.
And the node that is getting the events. Yeah, actually the events are not duplicated across nodes, but they are given to the node, and then that node goes down. So we need to process those events and send it to another node. Is it possible, or?
I see. So you're talking about a worker maybe that's executing. How does it?
Or the node taking the events for processing.
Right. Yeah. So that would be the worker.
Yeah.
And so the worker, pulls something off of the task queue and executes it, and then sends the result back, and then that result gets logged as an event in Temporal server. And so, and then it can pull for more events and do more. And so, if a worker goes down, another worker is going to pull, and it can get it instead. And so we try to keep execution sticky onto a certain process, but it's not. There's never a guarantee that it's all going to run in process, right? And so you tend to not want to have like a bunch of process state that you are like as an optimization, that's fine, but you don't rely on executing in process in your workflow. And so it can resume on any other machine that might spin up to execute it. And that's part of the magic.
Okay.
Does that make sense?
Yeah, so that other machine will have access to the database where you were, just now you showed where the network goes down and
Yep.
the events were stored in some kind of a storage, some DB.
Yep.
So that DB will be available to the other node to
Yeah.
process.
I might have 100 workers all polling the same server to get work to do. Yeah.
Thank you.
How well do you handle parallel tasks if I have multiple things that I want to aggregate?
Yeah. So, gosh, now I'm trying to remember what the Ruby idioms for this are, but parallelism is done with whatever your language idiom for it is. And so if you're doing like a scatter gather, you can just like code that up, and maybe you create 10 activities and put them in an array, and then you just await all of them. And so you're just basically using your in-language primitives, but instead of calling like threads, you're calling activities. And so really it's just code. And so it handles parallelism however you would in your language of choice. And then one other thing, the workflows themselves are, they use coroutines, and those actually run, they're like, what's the word? Parallel but not concurrent, or they're concurrent but not parallel in the sense of everything gets serialized at the workflow layer. That's kind of details. It works fine, is the TLDR. And then you can fan out to, a lot of people write fan out workflows that scale to thousands of, sub-processes, which are activities, or child workflows. You can build child workflows. So it's very scalable.
Sorry, one last question, I guess. Yeah, okay. So you showed in your demo, which was awesome, by the way, that if a workflow fails, one of the activities fails, you get an entry in that web UI that you're showing, and you can track the progress and see when it restarts and all that. But in a real application, I can imagine there being many, many more of those that fail because of the same bug. So we forgot to put a P on HTTP, so now we've got thousands of these that are in a running state. Is there a way to script the system such that you can restart all of those at once? Or I guess they would automatically restart, but is there a way to query that data to find out how many failed, which ones have failed, maybe stop a bunch of them because they can't recover, something like that?
Yeah, there is. So this is my list of workflows. Obviously, it's a very small list, but I can actually filter my workflows by various criteria. So I could do like the build ID, and then it's like, oh, everything that ran on this certain build that like was a bad build, I can find those things. Or I could say everything that started within the certain time range that I know is problematic. Or I can just like, oh, this one workflow type was hosed. And then I can also check on execution status. And so if it's like still running, it hasn't completed yet. So I can filter down, and this is all indexed in, like, I think the open source one uses Elasticsearch, right? So you just are querying for these workflows behind the scenes using Elasticsearch, and then you query them, and then you could like, in the UI, you can even do something. So you can check all of them. I can terminate all of them. I can reset them, and then it like gives me some options on how to reset in bulk. So yeah, you do a lot of stuff, and we're adding more. That's one of my projects right now.
And you can script that, for example, from your application?
You can script it too, yeah. In fact, the scripting has more flexibility than what the UI offers, yeah.
Awesome, thank you.
Thank you, Drew. Again, huge shout out to Temporal for releasing the first-party, kind of first-class integration for Ruby. And I think it's great because in my head, Ruby and Rails is perfect for your business logic, but for infrastructure, we should have kind of the best pieces of infrastructure for our Rails and Ruby applications. And we can only have that when, I mean, in open source, we can have alternative integrations, drivers, and like the original one, right, coming from Coinbase, correct? But it's best when the companies like that really recognize Ruby and Rails as a major market and really start kind of working towards getting us better and better support. So thanks.
Yeah, we're getting really good traction on the Ruby SDK. So lest anybody thinks Ruby is dead, like it is not. It is not dead. It is. There's been such a lot of, the community has been really great already. Yeah.
Thank you.
Just plug your laptop in. I guess I'll just use this one. Just gonna make sure I get the title totally right. Okay. All right, our next speaker is the inimitable Enrique. And he's going to talk about, the title is What I've Learned Building an MCP Inspector in Ruby. Take it away, Enrique.
Is this on? Yeah, now. Oh,
I had problems with.
Oh.
We can try both either way.
all right. So give me a second. Change. Entire screen.
Yeah, there you go. Perfect. Do you have speaker notes, or is this something?
I have a speaker notes, but
You do. Do you want
Yeah.
to show up?
yes. Can you? If that's possible. If not, I can work with
I
that.
might have to just say decimator and then just do change.
Oh.
And then just do
Extend it again.
yes, I guess so. Extend display, that makes sense. Yeah. Okay.
Yeah,
and
but
then
where
you-
is?
So go to that screen, like you get your mouse onto that big screen over there. Sorry.
Yeah, I don't.
Can you move your mouse over there?
Where is he?
Is it other way? There it is. Okay.
Oh yeah.
Play it over here. Hopefully, yes. There we go.
Yes. All right. Excellent. We did it. All right. So, how many here have used MCP? Okay, like the majority. How many here have built an MCP server? All right, just 10. All right, and how many have actually used the MCP inspector? 1. Excellent. Or maybe a couple. Oh, there's more. There's more. So, hello. My name is Enrique. I'm a software engineer at Handshake. Handshake is a company that is trying to democratize access to job opportunities for those who are starting in their career. Handshake is also working on providing human knowledge, expert human knowledge, to train foundational models. And let's look into the MCP fog. And I'm saying the MCP fog because I think it's like magic or mysterious and a little bit misty. So we don't know exactly what it is yet. So let's ask ourselves the question, what is MCP? And a few months ago, someone said that MCP is that weird San Francisco thing. They said that in this very Ruby Meetup. And if you speak Spanish, no, it does not mean más cerveza, por favor. So MCP is Model Context Protocol. And you can think of MCP as the standard way foundational models talk to each other or talk to external tools. So we're going to do a quick recap, so we're all in the same context. So the context is that as I said, it's the standard way, but it has access to the models. Foundational models have access to the entire internet, but they don't have access to your photos, to your documents, to whatever is internal in your site, on your computer. So a way that we can share these tools, share this information with foundational models is through MCP. And how does it work? It has, you can have a host application that can be either Claude, ChatGPT, or Gemini, and then you have clients that talk to the servers, and the servers are the ones who actually have the information. And this works in a way that is request response. So technically, you talk to the server, the client talks to the server says, oh, these are my capabilities, this is what I can do. And then the AI say, okay, give me something else, and the server will respond. So what does actually make an MCP server? The MCP server is three things. It's tools, resources, and prompts. Tools are things that you're going to execute or they're going to have on your computer, or they're going to give you access to the remote data. Resources are static objects or documents or photos that you have in an external environment. And then prompts could be either templates or something, a particular template or a particular prompt that is very useful for access the external information that you have. An MCP client, and I think that a lot of you have used this, is Cloud Desktop, Cursor, Whop, the terminal, or even the Ruby MCP client. All right, so what is MCP Inspector? MCP Inspector is a tool that helps you build MCP server. And it helps you build and debug. And I'm going to show you a demo of the MCP Inspector that was created by Anthropic. It's a JavaScript version. And I was very curious about how it worked. So before showing that, I'm going to show you, if I can find it, yes, an MCP server that I created for these purposes. So using FastMCP, which is the fastest way to create an MCP server in Ruby, I defined two tools, one for checking the fog in San Francisco, and the other one for give us some information or with some about the fog. I registered the tools and I started a server. All right, so let me go to the JavaScript inspector, and I'm going to run this command that is going to open a web application. And this web application will have a command here that's going to say which server is going to run. So I start the server, and I have access to resources that I didn't find anything, but I did define tools. So I'm going to go ahead and list the tools. And when I list the tools, I see that there's one for checking fog. And I'm going to say, OK, this is in the mission. And the mission is usually sunny, of course, like clear fogs, clear sky, sorry. And I'm going to check Castro. And, oh, Carl is there. All right. Well, and what wisdom can I get from the fog? Yes, always bring a jacket in July. Thanks, Carl. And as you can see, the requests and response are being monitored here, so you can inspect it. And that's MCP Inspector. This is the tool that Anthropic has been building to create MCPs. All right. So why decided to try to build an MCP Inspector in Ruby if the JavaScript already exists and it's very good? So the main reason why I decided to start playing around with MCP Inspector is because I wanted to learn about MCP. I wanted to see how it worked. I wanted to learn about the protocol. So for that, I started using these existing gems. These the Ruby MCP client and the actual official model context protocol, Ruby SDK, who is also maintained by Shopify. And the way I design it, the Ruby MCP Inspector, is I divided things into 3 layers, the transport layer, data, and presentation. And let's talk about the transport layer. So transport layer, if you think about it, is just the road. It's how you connect the client to the server. And the specification defines 3 options. One is standard input, standard output. The second one is HTTP. And the third one is streamable HTTP. All right, so I started by learning about how the MCP client does standard input and standard output. And when I look at the server, this is the method where I saw like how they establish the connection, how they initialize it. And it has 3 parts, which basically is connect, reader, and initialize. So I'm going to show you the connect version because I think it's very interesting. It's using a gem called OpenTree. And OpenTree is different from, well, it gives you access to standard input, output, and standard error, and also gives you a wait thread. And this is different from just using streams directly. So if you have ever opened a file directly, that gives you a stream, but that blocks your system, or that can block your system. And what OpenTree does is provide you with sub-processes for each of these. So basically, you can start threads and manage them. And that's exactly what they do on Start Reader. They actually created a thread and then started processing it with each line. And then the next thing is perform initialize. And this is the other part that is going to send data into the other direction. And as you can see, standard inputs is just streams that we have managed forever in Ruby. So nothing special, everything simple so far. So let's talk about the HTTP version. So if you want to connect a server with HTTP version, I think this is going to be look very familiar for Rails developer or web developers because it's just HTTP. And when I look at the HTTP correction, it's just Faraday. It's even more advanced than just net HTTP. And as you can see, it has like some interesting defaults that it has read timeout, max retries, and read timeout. And the adapter has been very well configured. All right, so the next one, this is the one that I was really curious because I've never used a streamable HTTP. So I wanted to see how it's done. And for this, I want to show you the server version from the official MCP because I think it's easier to understand. So in the initialization and the initialize, they have a hash to store session. There's a mutex, but don't worry about the mutex. And there's a method that will handle requests. And they have different types of requests, but there's one for get requests. And that's the one that actually it starts the process. So when we see that the streamable HTTP starts the process, the first thing that it does is get the session ID, then there's some error management, and then they set up the stream. And how does they set up the stream? Is just by creating an SSS body, and then you can see there's a proc do stream. That's the one that actually gets you a stream that you can send information to. And then this method store stream information just basically does is in the hash that we saw earlier, it puts the session ID and the stream. So even if the client disconnects, you can resume the session by knowing the session ID. So does this look familiar to anyone? No? Rack, anyone? So this is basically, when I Google about this, it's basically how Rack does the streams. And I got this from the Rack upgrade guide. It's basically gives you a stream, so you can just read and write from the same stream. So quick summary on what we saw from transport. If we're going to do standard input, standard output, we just use the OpenTree gem. If we want to do HTTP, it's just easy, Faraday, streamable HTTP, rack streams. So nothing complicated. We all have done things like that in Ruby. All right, so let's move at the part of the data. The data is basically what you're going to send in the transport, and basically what is the vehicle that you're going to have when sending the one data to other. And the specification says that this data is JSON RPC. In JSON RPC is just JSON, but plus a basic schema. And the basic schema says that you have to have the version of JSON RPC, an ID, and a method. So it's very simple. The most simple message that you can send in JSON RPC is just something like this, where you can list the tools. All right, so now let's talk about the presentation. And for the presentation layer, I'm just going to talk today about the CLI. the CLI that I created for the MCP inspector. And as a common Ruby CLI, I'm using Tor as the tool that I'm going to define my CLI. And here I have the list command, and the list command is going to take a type as parameter. And I'm going to be able to list the tools. And then when I call this list tools method in my adapter that I created, I have something called that with server connection that is going to give me 2 adapters. And the adapters are basically the streams from the transport layer that we saw before. And with these adapters, I can just say, I'm going to send information or I'm going to get information. And yeah, so let's jump into the MCP Inspector CLI demo. All right. So the first thing that I'm going to do is from the server, the SFOG server, I'm going to list the tools that we have available. So we have the check fog and with some fog. And then the next thing that I'm going to do is I want to execute the with some fog. And when I'm executing the with some fog, I can see that the response is just the JavaScript, that the JSON that I defined. And Carl's, the fog, knows all the secrets, of course. So now, I also set up something different, the server file system for MCP. And this one has a lot of tools. So as you can see, it works with the configuration. So in order for me to configure the MCP server, I have like a configuration file that is defined which MCP servers I want to interact with, and also I define which protocol I want to interact with them. And just as the last part of the demo, just like show you the names of the tools that I have available. All right, so let's go back to the presentation. The web interface is in progress. I haven't completed that part, but I have good news for you, that if you want to see it, you can come to the San Francisco Ruby conference in November, and I'm going to demo it there. And I have some things that I have decided what's going to be included. I'm going to make sure that it's rack compatible. I don't know if I'm going to be able to use the temporal MCP there, or if I'm going to need a proxy or Rails version, or maybe just Sinatra. And maybe I can reuse the web components that are already available. So I want to talk about that a little bit more. So the MCP server, the JavaScript one, already has components that are made in React that technically could be reusable. And I thought about that, so maybe that's something that's going to happen. Otherwise, I also can just do ERB or HTML. But when I was looking into this, I realized that I changed the MCP server and the UI or the component changed. So I was thinking about what would happen if we can start building UIs based on MCP server, and we change the MCP server, and our application magically has new fields or new items. So someone else thought about that pretty much at the same time, and they started building this MCP UI dev. And it was after I submitted my application for the conference. And they already have interactive components, web components. So I guess that the next part for the Ruby MCP inspector is that I'm going to have to make it web-based. And I would like to include support for MCP UI, which is very cool because they're sending the resources of the web components into MCP so you can actually interact with them. And they have already talked to the specification panel, and there's very likely that this is going to be approved by the specification. It's going to be part of the specification. And well, one thing that I really want to do also is make it Rails compatible. All right, and the last part I want to talk about is that this talk was not really about just MCP or AI. This talk was more about highlighting that we can build AI applications with the existing tools and resources that we have. And that I think that in the future, every Rails application is going to be able to function both as an MCP server or an MCP client. Just like today, every Rails application is an API application. That means that you, here in the community, you can decide what's going to happen, what tools we're going to have, or what applications we're going to build. So thank you for being here.
Questions? All right. That was a great talk, really inspiring, and thank you, Enrique. I'm really excited to see what you have, what you're building next. Thank you.
Sure, you're welcome.
All right, we'll now go into a break. And remember, right, so during the break, grab some salads and sandwiches over there on the other side. And don't forget that after the break, we have the open mic. So the open mic is for you to come to the stage and share anything you want to share, maybe ask a question, maybe announce, maybe share something about your new product, or whatever you want to share about. So for the open mic, we're going to just create a line here on this side right after the break. And then we'll have 3 more talks. Yep, see you there. See you in 20 minutes. 20 minutes. Thank you. Okay, how's everybody? It looks like people are quieter, no? All right, everyone, let's start getting back together. So who's up to speak at the open mic? Who's not shy? Who's not shy? All right, yeah, let's form a little line here. You can share your screen if you want to, if it's not Linux. I'm sorry. That's prejudice. That's discrimination. Call it whatever you want, but you can sit on the cool stools if you want to, Justin. By the way, right, let's form the line on the stools, because we have them, right? Perfect. Which way? I guess whoever's the closest is first, and then... Yeah, come over from the backside. Right, okay. So did anybody do anything cool this weekend? YC Hackathon. Wow, not bad. Okay, I wanted to say I was kayaking in Monterey, but this is better. What was it? Hot pot. This is Korean, right? No? Yeah? Cool. Oh. Nice. Perfect. Jesus, so good. By the way, I found a Swiss restaurant in San Francisco, so now I really want to do, what is it called? Fondue. It's like hot pot of cheese. It's better. Everything's better with cheese. All right. Right, so now we're gonna do, so this is my favorite part. Hope your favorite as well. So we're gonna do the open mic, and so the way we do it, each person, please introduce yourself, and then, try not to break things.
Hello. My name is Cody. I live here in San Francisco. Oh, I need to plug my laptop in. That would help, right? And I'm a founder of a company called Llama Press, which uses Ruby on Rails. There we go. A little blurry. But I'm actually here because I'm announcing a new project that we're doing. It's Llama Press is a coding agent. Right now it builds very simple front ends. It's just an HTML document with JavaScript and CSS, single page HTML web pages. And that's kind of in our hosted SaaS environment. But we're starting a new project where we have a coding agent that actually builds the full stack. So, we all love Ruby on Rails, right? It's the best framework out there, kind of the original one developer framework. And so this is kind of a project idea we've had for a while, but we just barely got our first version live. And we're here to kind of announce that. So essentially, it's a chatbot that builds Ruby on Rails apps, very similar to Claude Code, except it's in the browser. If any of you have used Lovable or Bolt or anything like that, very, very similar, but it's Rails specific, and it's completely open source and free. So you can run it locally. We have a single command that you can paste to run it locally or to deploy it as well on an Ubuntu server. And did anyone watch the Lex Friedman and DHH podcast? Yeah? It's like 2 hours. Yeah, it was long. But it's very interesting. DHH is always very interesting. But one thing he mentioned that really stood out was he talked about this, Rails being a very beginner-friendly framework, right? He talked about this soft ramp to infinity. Anyone remember that? And the idea is like, Rails is so easy to get started with, and you run just one or two commands, and you can spin up a full-stack web application. And the thing that excites me is I think that Rails has an opportunity to expand and bring in people who aren't traditionally developers. And something like this, if you can run a Rails application in the browser and talk to it, and it just kind of builds itself, I think that we could really kind of open this up for non-traditional developers. So I'll give you a quick little demo. I'm running this locally. You can send a message in, what routes are defined. It can read files. So right here, I went and found our config/routes.rb. we can say, what should we do? What feature should we do? Let's say, build me a registration for announcements at Ruby SF. And I know I gotta get off the stage here. Basically, it'll go, think through it, and then it'll make a game plan. You say, yes, do it. And it'll go, it'll read your files, it'll run scaffolding commands, it will, let's see. Okay, and it's thinking. It's going to generate a to-do list. Let's go over here and refresh. It's going to generate a model, migrate the database, create a controller, add a registration form, et cetera, et cetera. It has access to Git, so it can run Git status, Git commit, Git push. Continue. So I'm out of time. I know we got to get things going. So anyways, if this is interesting to you, I'd love to hear from you and talk after. So thanks.
Hello. My name is Yatish. I'm at Yatish_me on Twitter, GitHub. I'm a staff engineer at Asana. I was also the co-organizer for the SF Ruby AI hackathon. And that's where my interest of AI and Ruby got in. But what exactly is AI? It's just a fancy token generator. So I decided to start a weekly newsletter called as tokenruby.com. We already have few issues, more than 200 subscribers. So again, if you're interested in Ruby, if you're interested in AI, and especially the combination of two, go subscribe to tokenruby.com. That's it. Thank you.
How's it going? My name is Cole Robertson. I'm in the current batch of YC, summer 25. I've worked at a bunch of companies like Garmin, most recently Tropic as well, where I got my first exposure into Ruby on Rails. And there I saw like truly a one-person framework in action when our CTO rewrote our whole code base over Christmas break himself. It was fantastic. And then from there, I just have been chasing that forever and said, okay, when I'm going to have my own company, we're going to do it in Rails. And so I came from a big background of React, the whole JavaScript ecosystem, and something that I'd like to show today is kind of what we have in our application that we're using right now for our company, Describe AI, and kind of how we're managing and mending both Rails and React. Here's the dashboard you can see for our application. What we really do is we use computer vision to be able to 3D represent piles of stuff. So we take giant piles of grain, gravel, whatever it may be, and things that are like traditionally not in boxes and barcodes, and we tell you exactly how much there are in these piles. And you'd be amazed that the biggest companies in the United States are still guessing, where they're doing that jar game, where they're saying, how many marbles are in the jar? And they're doing that with their giant gravel piles. And so we're changing that. We're telling them exactly how much they have, and our whole web server and platform that we're using is in Rails. You can see that we have our Rails application here. This is using Rails with inertia, which the Evil Martians team has graciously been able to help really spearhead this React version of inertia. And so this is all React on the front end that you're seeing. It seamlessly integrates with Rails. You can use great libraries like this is Cesium with the React version of Resium is what it's called. And so you get all the nice shadcn stuff here. You get everything that you would like on the front end, the best of the front end and the best of the back end with Rails. So this has really changed the game for us, being able to do quick prototypes, to be able to make our whole MVP and a production system for YC within the ecosystem, React and Rails here. This is just a quick demo of kind of what we've got going here. But here's just for fun. This is one of the sites we did the other week. This portion here that you kind of see painted, this is an actual site that we did with our drone. to be able to get this like 3D representation here. And it's a little tough on the trackpad, but you can like zoom around, but these are like the real sticks that are on the site and everything. And we're able to tell them exactly how many sticks they have in this pile. So, yep. Thank you very much.
Hey everyone, I'm Avinash. I'm the co-founder and CTO of Cactus. I don't have a presentation. This was impromptu. I have been working on Rails for the last year or so. I'm new to the city. I came from Dallas to SF to be part of the Rails community. Went through the previous YC batch, and we are building an AI for small and medium scale businesses where they can qualify and follow up with all of the leads that they get in. So we are building voice and text AI platform. And we basically are looking to hire senior Rails engineers. So if you are interested or if you know anyone who is interested, we are a full stack Rails shop. And we'll be working together to build the voice AI infrastructure for Cactus. So hit me up if you're interested. Thank you so much for this opportunity.
Wow. I love giving presentations in the era of USB-C. This is so great. Okay, all of the resolutions have changed. I'm sorry. Here we go. Okay, so my name is Andre Arco. I am possibly better known on the internet as Indirect. I work for Spinel Cooperative, which is a collective of Ruby open source maintainers that I have recently started with some other Ruby open source core team friends. And what we do as a company is offer retainers to other companies that need help dealing with their open source dependencies that we have been on the core teams of, like, Rails or Hotwire or Turbo or Ruby Gems or Bundler or whatever. I guess there's the pitch. If your company could use really super expert stuff, we do retainers. Talk to me later. But the thing that I actually want to show you is a tool that we are working on building. I'm calling it RV, kind of inspired by UV from Python, if you've heard of that. It is, I guess we have very high ambitions, but so far all it is a basic Ruby version manager with a little bit of a twist. The little bit of a twist is that you can install Ruby really fast. So let's try that. That was it. Ruby's installed. It takes 1 second. If you've had to deal with other Ruby installation management systems, this will be better than that. Check it out. Our company website is spinel.coop, and the GitHub repo for RV, which has a homebrew formula and all that good stuff, is at github.com/spinel-coop/RV. Cool, thanks.
I know, that's what I said. She was like, how long does it usually take to build Rubies? Well, I'm Justin Bowen, and I'm tons of fun. And what's more fun, I'm tons of fun on the internet, but what's more fun than being with Ruby friends at Ruby events? That was just for Marco, because I know he's going to watch this. And he's going to like put timestamps on everything. And I'm actually, I think I often announce new minor releases of active agents here. There was a new release this morning. 0.6 is out, and there are a lot of cool examples. Yeah, woo! Another minor release, but this one's cool and has a lot of cool documented examples of agents you can use. Like, I made a capybara cup-write agent that can browse the internet, and that might actually help Marco and the Ruby events people browse these events for different websites. There's also a data extraction agent example for structured output. And there's a new feature that's going to be in 0.6.1 later this week that's going to be output schemas from active record and active model schemas, because did you know that active model has types and so does active record? Yeah, it's pretty crazy. Yeah, and then there also might be some examples of agents interacting with active record, but yeah, check it out. Activeagents.ai, docs.activeagents.ai, I should say. Better than that, yeah.
Hi, everyone. My name is Rhiannon Payne. You may know me. I do marketing for ActiveAgents. So if you go to activeagents.ai for a limited time, you'll be able to see a website that I'm going to be completely changing soon. Go to docs.activeagent.ai instead. It's a better place to be. So why am I up here? It's not about ActiveAgents. You may know me from my work also doing marketing for Ruby Central. I've been the marketing director there for the past 10 months, leading marketing for RubyConf and RailsConf, as well as cool open source Ruby Gems stuff, all the things. And this isn't related to that either, but kind of. So at the Ruby AI Hackathon in July, I presented a landing page that I vibe coded about my idea for a Ruby book. And this is not a technical book because I am not an engineer. My idea was to actually pull together the interesting human stories that have shaped the language and the ecosystem over the last 3 decades. I believe, if I remember my notes correctly, I believe that Rails just turned 25, is that right? 20, okay, thank you. I didn't remember my notes. But that being said, I think that now is an amazing time to sort of pull all of these legacy, 20, thank you, Irina, it's on her sticker. Pull all of these current and also legacy contributors and people who've been involved in shaping the ecosystem, getting their stories and kind of telling that human story of the passion behind this, because Ruby is the most human programming language, and why not share its story from a human perspective? So I am not necessarily writing this book, but if you like the idea, I can. I'm currently chatting with folks, both companies and organizations, about potentially becoming a creative / financial partner to work with me on the project. If you or anyone you know might be interested in having that conversation and being part of helping me shape this story and really preserve the community's history, let me know. I will also be at Rails World in Amsterdam next week and always here in San Francisco. Okay, thank you.
All right, this week I have been working on a gem, and while this thing loads up, how many of you have ever worked with forms in Rails? Let's see a show of hands. Oh my goodness, everybody? How come only half of you have worked with forms? All right, I don't even want to know. All right, for those of you that have worked with forms, I've been working on this form helper called Superform because I have worked with all the form helpers in Rails, and it's not great. So what I want to show you is Superform was built in Flex, but this week I put a lot of work into making it awesome in ERB, because everybody uses ERB, right? Nobody knows what Flex is. So it works great in Flex now, and this is cool. This is what it looks like in Flex, but who cares? You know what? Who cares about the ERB stuff? The thing that I made official was if you build your form using Superform, you automatically get strong parameters with it. So this is how you throw your model inside of a form, and then if you call if save and you save the form, it permits the parameters for you. You don't have to maintain the strong parameters things. So there's no more like, why is this damn field not saving? Oh, I forgot to permit a parameter. So that's what this thing is about. The second part related to this repo, I threw this tweet out about, it was kind of a subtweet, and it's like, hey, if you're throwing a new repo out into the world, you should probably compare it to all the other repos. rpush, active alert, or whatever it is. Anyway, I wanted to show that in this repo, if you go there, there's comparisons with Rails form helpers, simple form, and Formtastic. Like I said, I've used all the form helpers in Rails. These are my, I guess, battle wounds from it, and I wrote about it in that repo, so if you're evaluating this against the others, you can kind of see what's going on there. And why did I do all of this? Did I do it because I like forms? Yes. But I'm also about to shoot the form section for the Flex on Rails video course that I'm working on right now. So it's for Flex, but I figured why not make it better for ERB since everybody uses ERB. And I hope Superform is like the gateway drug into Flex, which is why if I tweet about Flex, it's always this like strong arm emoji followed by a pill. That's it, the end.
Okay, I wonder, for some reason I was wondering how many speakers at today's open mic were not YC founders. I think it's less than half. Yeah, just testing. Rhiannon is a founder, she just didn't tell you. Miles? Oh, question? You're not, yeah, just a few. Miles? Oh, are you using my computer?
I can try this first.
Okay, let's try. So we are breaking the rule number 1, which is the number 1 rule of our meetup, which is do not stream presentation from Linux. You see, it's not working.
It's weird.
It's not working anywhere. It's not. Come on, take a Mac.
Okay.
Take it.
It worked earlier. I'm so mad. Yeah, it wasn't.
We got it, no worries. We got a Google Slides presentation. Oh. Okay, what else? What else cool did anybody do this weekend? Other than the hackathon? Driving from LA. Wow. Was it beautiful at least? It's not worse and worse. It's better and better. You'll see. Sitting with Justin's cat on the couch. It's pretty good. I did it.
Okay, cool. Thank you so much. Ooh, it's a hot mic right there. Should I give you one of these mics?
Oh, yeah.
Okay. Hello, my name is Miles Georgi. I wrote a framework called Foobara, and I wanted to chat a little bit about what inspired me to do that, chat about my journey and what it is. So what is Foobara? It's a framework for building command-centric systems that are discoverable. So command-centric and discoverable, these are the 2 pillars of Foobara. And why did I want a framework like this? For dealing with projects with lots of domain complexity. So I was going to give a timeline, share a little bit about me and my past and my journey. So I started programming in 1995. Nothing interesting happened before that. I don't know what happened here, though. I think my palm must have touched the touchpad. There we go. So then I was fortunate enough to be able to start programming professionally in 2001, discovered Ruby in 2007. Around this time, I wrote a gem called Externals, which helped with having sub-projects managed by both Subversion and Git, which was actually helpful at the time, believe it or not, before kind of Ruby gems took over that role. Got my first Ruby job in 2012, which was great because it was my favorite programming language at the time. In 2013, I discovered a gem called Cypress Mutations, which implements a command pattern. Does anybody here happen to have used that gem? No? I really love this gem, and I've used it in every Rails app ever since. But we used this gem to manage the domain complexity, even though the domain complexity was really small in this project. There was no complicated domain complexity. So in 2014, I had my first encounter with a complex domain. So this was a mortgage product, And we did everything. So we did top of the funnel, origination, servicing, loan sales, funding the loans, and we funded the loans by both institutional investors and peer-to-peer lending. So the complexity here was just off the charts. And it was really fascinating to run into a project where the challenges were not technical, but rather just domain complexity management. So then, fast forward, coincidentally, I ran into a second project with a complicated domain in 2021. Completely different team, completely different project, completely different tech stack. This was a Ruby project, whereas this project was a Node backend with a JavaScript front end and React. But this project here, its domain was making it easier for people who normally don't apply for electric vehicle benefits like tax credits and rebates to actually apply for those benefits and purchase an electric vehicle. And something that really shocked me was how many recurring problems happened, how many problems were very similar to the mortgage application that seemed to have nothing to do with the team, nothing to do with the tech stack, and it was really just poor management of the domain complexity. So that was really surprising. This spot in here where it looks like nothing was happening is basically domain complexity beating me and my team up pretty badly. Here, though, I encountered my third complex domain, and this was very similar to the EV project, but was solar panels. A difference here is that I was the engineering manager for this project, and it was a greenfield project, and I had carte blanche from the client and the employer to manage this however I wanted. So I was able to put to the test a whole bunch of hypotheses I had formed over almost the previous decade about complicated domains. And this project, one thing I did, by the way, is I introduced Ruby on the back end. Since this project here was Node, so here we introduced Ruby on the back end. But anyway, this project was a success, and it inspired me to create a framework based around what I had learned that I wish I had had when trying to deal with these other complicated domains in the past. So I started Foobara then, and that brings us to now, I guess an unsanctioned use of the SF Ruby logo. Hopefully that's okay. But yeah, so getting back to Foobara, it's command-centric and discoverable. I'm going to dive into command-centric first. So what does it mean to be command-centric? Command-centric system uses commands as its public interface, and as its public interface, the public interfaces of its subsystems. And what is a Foobara command? A Foobara command encapsulates a high-level domain operation. So showing some code here where the domain logic is not encapsulated. The exercise is to try to spot the domain logic. I'll just skip ahead here. It's in blue, or at least what I considered the domain logic is in blue. What's in red, I would consider integration code, in particular HTTP integration code. Am I too far from the mic? Okay. So here's a command example. This is, we're going to encapsulate the make reservation command. I have a little comment here about mental models. We're going to call it make reservation, not create reservation, even though we plan to use it in a create controller action. So this is a make reservation command for a hypothetical capybara cafe. And you can see the command has a name. It optionally could have a description, but this one doesn't. Has inputs, which is a type, result, which is a type. Execute is an opportunity to write a self-documenting method that communicates what's going to happen if you choose to run this domain. And the rest of it is implementation detail. But the important thing is all of this is domain logic. So how do we run it? Coming back over to our reservations controller, we're running it down here where you see make reservation.run. All commands have the same interface, and this interface is taken right from that Cypress mutations gem that I mentioned before, so it has basically an identical interface for calling commands. All of this now is code specific to how do we expose our make reservation domain logic over HTTP. So we now do have that separation of concerns. Benefits of encapsulating domain operations. Now the domain concepts are clearly represented in the code base, which they were not before. And if you're struggling with domain complexity, this is the biggest benefit. You get a couple others because you are separating concerns, so you also get code reuse, improved maintainability. I was going to talk real briefly about mental model mismatches. Here we have our reservations controller, has create, update, destroy action. I threw in a time slot controller. The exercise here is to guess what domain operations are being carried out here. We already know that create carries out the make reservation operation, but what about update? Well, in my experience, update could be almost anything. And often there's multiple domain operations behind an update action. So I can't even guess there. What about destroy? I would guess cancel reservation, but it's not guaranteed because maybe I need to change an is canceled flag in the update action or transition a state machine in the update action. Or maybe the state machine is exposed as a resource in some other controller. Or maybe there's a custom cancel action that someone introduced. A tension I've noticed on a lot of teams I've worked on is some engineers will want to introduce a custom action like cancel because they're trying to express the mental model. And the other engineers on the team understand, well, this is a RESTful architecture, so we can introduce a cancellation, but we can't introduce cancel. So there is a mental model mapping here. Time slots controller index, all I know is that's going to be returning a list of time slots. So let's take a look at the answers. Turns out update is for reschedule reservation. We were correct about destroy, and it turns out that index on the time slot controller is check availability. Something that I've noticed is that in a lot of projects, we might just expose all the time slots from the back end, and it becomes the front end's responsibility to interpret those time slots to figure out availability, which is probably the right trade-off if you have a small level of domain complexity. But I believe if you have a very complicated domain, you don't want the front end and the back end both owning their own interpretation of what it means to be available. You'd rather, if the back end owns that, to impose it on the front end. So yeah, anyway, back to Foobara. I'm going to blast through here. This is kind of another view as the other one, but we're looking at the file system. So here, we're using commands to separate concerns at the file system level, and you can see we do have a separation of concerns here. I still don't entirely like this for multiple reasons. However, we have separated those concerns, and this is somewhere where I think a lot of teams would naturally wind up if they were trying to manage domain complexity, whether they're using commands or some other approach. So yeah. Let's move on to discoverability, which is the other pillar of Foobara. So what is it to be discoverable? A discoverable system provides formal machine-readable metadata that describes its operations and the concepts those operations depend on. So here I have a small example of some manifest metadata. It's truncated. There's a lot more here, but you can see information about the inputs type. The important thing to point out here is that all we did was write our make reservation command in our Capybara Cafe domain, and we automatically get the formal metadata. And so what happens, what's the implication of adding discoverability to the system? Here I'm using purple as a combination of blue and red, which I've mentioned is bad, although that is specific to if you're trying to wrangle domain complexity. So we already saw that if we make it command-centric, we can get this nice separation of concerns, and this actually helps a tremendous amount. For a lot of projects, this might actually be enough to achieve success. But what happens if we add discoverability? Well, we actually wind up with this. And the reason we wind up with this is that if you do a disciplined job of adhering to this approach, these controller actions, jobs, and rakefile tasks start to become really boring and repetitive. Normally what I wind up doing if the project is really well maintained is I need to add a controller action. I'm going to go copy an existing one, change the name of the command, maybe tweak the way I'm casting the inputs, but nothing else. Same thing with the jobs. I'm going to go copy an existing sidekick job, change the name of the command. Rakefile task, I'm going to copy and paste one, change the name of the task, change the name of the command, I'm done. So these become very boring if you are being disciplined about this. So what we can actually do is use that formal metadata to just abstract away all of that integration code. It's no longer interesting. It's now a good candidate for automation. So benefits of adding discoverability, just mentioned the integration code can be abstracted away. The domain logic is less likely now to creep in into the integration code. In fact, it can't creep into the integration code because there is no integration code for it to creep into. And now the mental model is not only communicated, but dominant in the code base. And so if you're struggling with domain complexity, this again is the biggest benefit. So coming back over here, here the mental model is a complete secret. No one knows what the heck it is. Here the mental model is being communicated, and here the mental model is being screamed in your face. Like you can't miss it. Yeah. So coming back over here. Oh, and then one more. You do get faster development and testing. If you're not writing controller actions, you don't have to test those controller actions, so on and so forth. Again, that's not the main benefit if what you're struggling with is domain complexity, but it's certainly nice. So here's some other concepts. I'll probably move through here pretty quickly. I intentionally made command the only primary concept as a reminder to myself that the system needs to be command-centric, and that's helpful to me. All of these ones that are in color are things that your engineers would be writing to implement your domain, whereas these ones that are not in color you would use from Foobara or some third party. And also the ones in color actually represent your domain, so there's a connection between what you're writing and what reflects the domain. So I have a bunch of slides with code examples instead of a code demo. I'll probably blast through this, and you can find code demos online if you want to. Here's a CLI connector, so this lets me run various commands on the command line interface. Here we have a rack connector with an example of authorization. So we'll allow the authenticated user to edit the post if they own the post. And you can use this authentication with any command connector. It's not specific to rack or HTTP or whatever the case may be. But running this command connector allows you to call the commands over rack. You can even put help in the name of the command or the name of the type and get HTML help about it, all generated from that metadata. Here we have an MCP connector example. Just connecting it with a couple capybara-related commands. And if you do this, then you can tell something like Claude Code to manipulate your capybaras, and it'll oblige. Here's another example using Foobara agent, which is an agent written just with Foobara and actually functions like an alternative to MCP, which is interesting. I'll probably blast through some of these to save some time here. Oh, here's an interesting one, which is this uses a Foobara active record type gem. This lets me use an active record type as if it were a Foobara entity, which means I don't have to load the thing in the command, and I also can optionally use just the primary key or the record if I want to, which actually comes in handy for things like authorization. Domain mappers, I'll skip through that. Here's actually exposing some commands through Rails. In this case here, I'm using some sugar, which is just this command method, which is really just calling connect on the command connector, passing all this stuff through here. Something I'm doing is I'm actually moving some data from the result to, in this case, I'm moving the refresh token to a cookie, and I'm moving the access token to a header. So here in the command connector, I'm actually configuring how I would like it to be connected. I am not putting this kind of stuff in the command itself. Here's an example of a remote command. So you can import commands from other systems and run them locally. So, and something to call out here is that this remote command has the exact same interface as a command you write locally, which means if I want to, I can actually turn around and then expose this command over, like with the MCP connector or whatever. I could have Claude Code run this command without knowing that it's actually just a proxy to a command running in some other system. There's a whole bunch of code generators. I use these TypeScript ones a lot. Let's keep moving through here. Here's some generated TypeScript code. It's not quite as pretty as the Ruby code, but it has the same exact interface to the extent that is possible, given the differences between the programming languages. But I'm creating a command with the inputs. I'm running the command. I'm checking if the outcome is successful, so on and so forth. Here's an example of an agent-backed command. In this case, I'm writing a command that does not require an execute method, because in this case, the agent-backed command, it's actually going to use an agent as its execute method, which is just going to choose which other commands. This is actually a way you could fill in a gap in your domain that operates by using all the pieces of your domain that actually do exist. So that's actually a pretty interesting thing to play with. Here I have an example of an agent back command. Another example, this one here is using ChatGPT. Oh, this is getting really big here. Something to point out here is that because I've specified a result type, and here I'm specifying that the result is going to be an underwriter decision, so even though this is ultimately coming from an agent using an LLM, I can actually use this programmatically. So I can ask the decision if it's denied. I can access its denied reasons. It's a proper, full-blown underwriting decision, even though it came back from an LLM. So I'm able to make use of the result programmatically. Here's like some output, probably not all that interesting. You can see GPT and Claude are coordinating here because I specified different models on the agent-backed commands. And then this is that output that came from the programmatic use of the result. I did want to show something that I found interesting, just to show an interesting piece of Ruby code. In the Foobara agent, its main command for getting things done is this accomplish goal command. And I've highlighted these 3 lines because they basically summarize the algorithm, which is basically until the mission is accomplished or we've given up or we've been killed, determine the next command and inputs and run the next command. And this just runs in a loop. And I was surprised that this worked, but it worked. And I actually don't know how other agents work internally, but I have to imagine it's something like this, but with a whole bunch more optimization stuff. You can see I've introduced a little bit of optimization already. It gets in trouble if it doesn't decide to describe. It has a command called describe command. Some models will make use of it and others won't. If the model doesn't make use of it, it kind of starts just guessing how to run the commands or even what they do. Oh yeah, so I was gonna just mention something about Foobara, just trying to summarize my thoughts on it. The goal of it is you write your domain logic and then Foobara does the rest, which you can hopefully kind of glean from some of the examples. And then something I was going to point out is that Foobara commands are forward compatible with new integrations and new versions of old integrations. So for example, when MCP became really popular earlier this year, I wrote an MCP connector for Foobara, and all of my existing commands automatically could be called by Claude Code, and I didn't have to refactor any of them. And I don't ever have to write that MCP connector again, but although I'd probably have to be the one to maintain it since other people are not going to maintain it. But if you were using it, you wouldn't have to maintain it, and it'd be a new version of MCP comes out. You just bundle update, you get a new version of the MCP connector, and your commands should continue to be callable by MCP clients. And also I found it was interesting that I was able to write that agent. That agent you saw just uses Foobara in the standard Ruby library. It's not using any other libraries. And it was pretty easy for me to use Foobara to write a alternative to MCP. So I found that kind of interesting. Yeah, so I don't know about a time check. I was gonna mention why I chose to use Ruby for Foobara, but probably short on time. So I'll blast through here. There's a bunch of these. Ruby gems was a big one. I think we sometimes take Ruby gems for granted in the Ruby community. When I went from that Node backend project to using Rails on the backend on the next project, I realized, wow, I really missed Ruby gems, and I had no clue that I missed it. So yeah, leave the Ruby ecosystem and come back to it, and I think you'll appreciate Ruby gems. Thank you. It has a friendly community, and it's fun. Another reason was that Node runs on an event loop, and I knew I wanted to handle, you can use Foobara for more than just a web server backend, but I knew that was going to be a major use case that I wanted it for. So handling a request response lifecycle to me makes sense in a threaded environment, but not in an event loop. So I really don't like writing server-side code in an event loop personally. Especially when my goal is, writing self-documenting code, so on and so forth. So that was actually another factor that's not mentioned here. And that's it, yeah. I don't have a capybara in this QR code, but I loved that tardigrade, so I need to figure that out now. But yeah, and yeah, if you're interested in building something with this or contributing art, code, if you want to pair on stuff, I can pair on projects with you, your projects. Yeah. Anything that might be interesting about this or whatever, if you just want to talk about domain complexity and so on and so forth, just get in touch. You should be able to find me through this QR code, or I'm in the Slack as Miles. And that's it, I'm pretty sure. Thank you.
Okay, just one question, but we'll have to move on.
How does error handling work?
Just long story short, various things in Foobara have a concept of possible errors, and they'll return metadata about the errors that they can return. So that TypeScript-generated code, it actually generates all the errors that could happen on the back end. So if you actually want to react to them, you can. So yeah, I guess I don't know specifically what you mean by error handling, but errors are in that manifest. It wasn't shown, you just saw a little bit for a command, but there's errors, types, commands, domains, and organizations. All of their metadata is in that manifest. Yeah. Mm-hmm.
Awesome. Okay, let's yeah. Thank you, Miles. Great talk. Yeah, we'll have to move on because we're going to be kicked out of here at 8:30, but I still want us to have a little bit of time before that. So we have 2 talks. We'll try to make it fast. One is actually from me. And thank you. Thank you. For some reason, I don't get to do them a lot here. Yeah, I'll try. Yeah, cut the tests, right? Like, yeah, I'll have to chop, I guess. Jesus. Same thing with the display. Should I do full screen? Okay, problem is, I'd love to see the speaker notes. Okay, whatever. Let's forget about it. Got it. Okay, I think I got it. Sorry guys, I'm really sorry. No. That's not how it's supposed to work. Okay, for some reason, yeah, I should have used the Linux, obviously.
Is this a keynote?
Yeah, this is a keynote.
There,
Okay.
Put it over there.
I got it. I think I got it. For some reason, if it just doesn't magically work, then it's kind of a bit more tricky. All right, we almost there. Yeah, all right. I actually need the speaker notes because, folks, you know me, I'm Irina, I run this meetup. I also have a day job, which is running a company called Martians. We are pretty fortunate to work with a lot of Ruby startups and other startups. We mostly do dev tools. This is our focus. We work with startups, just help them build. We also help lots of startups with their dev tooling, with their dev productivity. So this is, I wanted to use this chance to maybe try and talk about one of the experiences and also hopefully talk to you all about speeding up test suite. So who's here, who can say that, okay, you feel like your CI is slow? Great, this means you're writing tests. Thank you. So this is, by the way, okay, this is kind of like, yeah, that's Labubu, if somebody doesn't know. So apparently, I just wanted to say thanks, again, thanks to GitHub. I wanted to say thanks to Rhiannon for introducing this idea of Octocat as Labubu because, yeah, apparently we're going to have a shop in San Francisco with Labubus. So now you know what you want to buy there. Anyway, sorry, let's go into this. So this is something we did for Whop, and Whop is a great fast-paced startup built on Rails and Next.js. So they reached over $1.5 billion transaction revenue, and it's built by, can I say, 21-year-olds? Okay, now maybe 23-year-olds, yeah. Like a very cool team that chose Rails, even though they didn't have a lot of experience with it. So Whop is something like a chat-based commerce platform. People my age called it Gen Z commerce platform. People their age call it just a commerce platform, so I don't know. And Jack is actually, the CTO is doing a talk at Rails World in Amsterdam about it, about scaling on Rails from 0 to a unicorn. So this is pretty cool, check them out. Okay, so what we did is, again, they reached out with the problem of slow tests, which is pretty common. So the stack was Rails, RSpec. We noticed they used TestProf, which is our open source toolbox for speeding up test suite. They also used FactoryBot, which is also pretty common. Now, if you don't know, this is TestProf. It's pretty popular open source tool. How many people actually heard about it? Okay, like 40%. So this is great because I'm gonna give a little background on this. TestProf is actually two things. So one is a toolbox to profile your test suite, to figure out what's running slowly, what's making most database calls, how they are structured, etc. So profilers. It works for RSpec and Minitest. Doesn't matter. So it has StackProf integration. StackProf is a profiler for Ruby. It has something called FactoryProf. So FactoryProf is a profiler to see which factories are created. TagProf, and there's a bunch of them. TagProf, EventProf. So it's kind of like it's not a single product. It's actually a bunch of tools. Now you need to know how to use them to speed up your test suite. But that's not all. It also has helpers to speed up your actual tests. So it's not just showing you which tests are slow and why they're slow. It gives you really nice helpers to speed them up. So we're going to talk about it. But basically, you have let it be. Let it be creates data objects for the whole context instead of for each test. Factory default, we'll talk about it. So let's get to this work. So imagine you have a slow test suite. And again, I'm using the example of that work we just did. So the first thing we do, we run a profiler, a StackProf, on a sample of tests. This is important because I'm pretty sure you have thousands, tens of thousands of tests. So if you run it on all of the test suite, it's going to create too much data. It's going to be really kind of tricky to navigate. So usually we run it on a sample, and then we look for the report. The report, we are also generating it. We're kind of generating the report, and then we're looking at this flame graph with speed scope. So it looks something like that. How many of you have seen something like that, like flame graphs like that, right? So you might be profiling, maybe not exactly your test suite, but you might be profiling lots of other things, and usually the output looks something like that. So basically, I think the projector is not focusing really well. But basically, you get the idea. You don't need to read the text. You basically just see, okay, these methods are taking most of the time. And these were the most time-consuming methods. What we noticed were heavy database activity, as usual. which means that there are, lots of factories, lots of data created in the test. There were calls to external services that were not mocked, which sometimes is intentional, but usually is not. But also, we found this, that a significant amount of time was spent on logging. So it's actually kind of crazy. Let's just switch off logging in our test environment. It's kind of taken, 2 lines of code. We also found something a little bit trickier. There was a custom sentry logger. So we had to kind of disable logging there as well. So it was not logging, it was login to sentry. But again, we don't need it in testing. We're not really checking logs there. And now, okay, we just disabled that. How much time do you think we saved? 20%. 90%. Yeah, so on average, you're correct. Yeah, 50%, seriously, 50% of the CI time in this real big production app handling billions of dollars was just saved with this. So this is time on local machine, and this is on CI. So it's 4 minutes versus 2 minutes, and 25 versus 12. This was the actual kind of CI speed up. Yeah, thank you. So again, really easy. You know what to do when you come home. When you go home, you check your test RB, okay? Now, the second thing, now, the second stage. Okay, we did this simple stuff. Let's go a bit deeper. Let's check out our factories. And in simple words, okay, next we are kind of profiling our factories. So we are trying to figure out, where we, which factories are getting created essentially, and also stacks of factories. So the first optimization strategy is just to create let it be when we can. So if we can create one factory for the entire context, let's just do it. Let's reuse the same data. So we just replaced let with let it be. Easy. Of course, we have to be careful. Think what we're doing. Second strategy is it's a bit more interesting. We create reusable associations. Because the problem with factories is that if you look at factory bot and you compare how many total factories are created versus top level factories, you will see if you have a lot of associations, meaning data being created because there is an association. So basically we can use something like another helper, create default, and this helper basically allows these factories reuse the same association. So it will not create, so imagine these two factories would have to use the association on bot, right? So they would just use the same object. So that's pretty cool. What do you think was next? So when we, of course, speeding up tests, you kind of have diminishing returns. The longer you do it, the smaller benefits you get. So you imagine we fixed most of the problematic places with factories. What's next? What do you think? Like what's, assets? Speed up the app. That's a good idea. Well, yeah. Yeah, superconductor. Yeah, by the way, very close, very close. So basically we do parallelization, better parallelization. And superconductor is also doing parallelization. So Justin's actually right. Perfect. So I don't know how many of you used this gem parallel tests. You might not realize that you're using it for parallelization. It's very common. It's incredibly common. The problem with it is that it kind of parallelizes tests by files, by test files. And this is not always fair, because you might end up with one process running your heaviest tests that are in the same file. So instead of this, we can use test queue, which is a bit more fair. It splits tests by individual tests, individual examples. So you'll be able to, basically you end up with better, more fair parallelization. So we switched to this, and you know what happened? It was like a nightmare. So it was the sea of red. Everything fails. Kind of like nothing works. Very cryptic errors. So it turns out. Sorry, guys. Turns out. Tests were flaky. Yeah. Tests were flaky, they were not isolated, they all depended on the order of execution inside the file. I mean, yeah, that's what you get when you're not really testing anything else. So basically, yeah, it just exposed a lot of problems that we had in the test suite. And how you think we fought this? Randomize the order. Yeah, so essentially, in some sense, this test queue is kind of doing that, because it is kind of randomizing individual tests. The problem is, okay, now we have flaky tests. We know that flaky, and okay, I'll cut it short. There was not a silver bullet. You'll have to read the whole blog post. Yeah. Yeah, to be honest, this is where it gets messy. So fixing the flaky is more of an art than just me telling you, oh, use this, just use this tool, use this gem or something like that. So we fixed the flaky, but yeah, you'll have to go find the article. It's coming out soon. You can sign up to our newsletter to not miss it. And yep, that's the talk. I'll just give a shout out to my colleagues, Julia, Igor, who actually did this work, and Travis and Vova, they are working on the blog post, and Vova is the author of TestProf. So yeah, that was me. Thank you. Thanks a lot. All right. So who's ready to look into TestRB? TestRB? Anybody? All right. Maybe with Superconductor's help. Maybe Superconductor can fix your flaky tests. Can it? Can it? Let's try. Okay. All right. Sergey, take it away.
All right, I'll be fast. But how do I plug into this? Oh, here it is.
Everybody has USB-C.
Yes. Choose to mirror entire screen. Yeah, this is good. Hello. I'll be fast because I know it's late. But my name is Sergey. I'm co-founder of Volition, which develops products, currently Superconductor. Previously, I co-founded Gradescope, which was an ed tech startup. It's a grading solution for professors. A lot of students have been graded on it. Previously, I was a TS PhD at Berkeley, which is how we got into this Gradescope. We had to TA exams, grade exams. I was at UW, just in case anyone has a Seattle connection. You can talk to me. I heard a womb, all right. And then, and I just recently moved, well, I was here for grad school, then I moved back to Seattle, and I just moved back to the Bay a couple of months ago, so. And then I've been building with Rails ever since college, so. How did we used to code? We used to code by hand, and we used to look up answers on Stack Overflow. And then very rapidly, people started coding with GitHub Copilot and then Cursor and talking to ChatGPT about their questions. And then for us, it was just in the last maybe 4 months. For some, it hasn't happened yet. For some, it was maybe a little bit earlier. But people are coding by guiding AI agents more and more today. And basically, that means you've just been promoted. If you were an IC, you're now a little bit of a manager. You have a number of Claude codes or codexes at your disposal. They're junior. You're still in the loop. You must still understand the problem that you want to solve or you want them to solve. And then you must still understand their solutions. I don't think those two things have changed. And this was also DHH's point, I think, about AI coding is if you let the AI do the coding for you and you just skip the understanding part of it, then that's not going to work out very long. But if you have the junior developers do the work, but you still understand what you want them to do and how they did it, then I think it can be very productive. One rule that I think you should have is no code should be shipped to production without human review, for example. And also, I think frameworks like Rails are really, even though it's easy to vibe code something that's like Rails, that does the boilerplate for you, I think it's a lot more trustworthy to actually use something that's open source and that many eyes have looked at versus something that was just vibe coded and might have some bugs in it. So there's coding agents in your editor nowadays, right? Copilot has chat, Cursor has agent. You can have an extension like Klein. And then there's command line interface tools like Claude Code, Codex, AMP. Who has not tried it? So we've all tried it. I think that's how good they are in that order. I think Claude Code is the best so far, or still. Codex with GPT-5 is now, I think, almost at parity. AMP is kind of a upstart that seems pretty good, a little bit faster than Claude sometimes. The others I haven't found to be worth it just yet. Gemini has been pretty bad, but I think might be getting better soon. Open Code can let you use models like all kinds of stuff. Cursor has a, but this is what it looks like. Some notes that I have, it's not hard to build an agent. You can actually build an almost state-of-the-art agent on SweBench, which is, by the way, mostly Python. I don't know if you guys know that. It's all Python, and it's mostly Django, actually. It's SweBench, but in 100 lines of Python, you can build something that gets like 68% on SweBench with Claude, I think is the model. You might have heard like Quant3 Coder is on Cerebrus. You get like 1,400 tokens per second. By comparison, Claude Sonnet is like 50 tokens per second. The problem is the rate limiting is still pretty brutal. So it's fast when you get the request, but you can only do like 10 requests per minute. And so it doesn't quite work for this agentic coding yet. Local models are just not powerful enough yet. So it'd be cool if we could just code on the plane without Wi-Fi, but that doesn't quite work yet. And I think in the long run, you might be tempted to work on your own agent or be convinced that some agent is much better than others. But I think it's mostly the model, like Claude Sonnet and Opus, or now GPT-5. They're just the best models. It almost doesn't matter what harness you put on top of it, as long as it's reasonable. And pretty soon, the next version of the model is going to subsume whatever harness you might develop, which is called the bitter lesson. My lessons for getting the most out of agents is, one, use them for everything. Make sure you write a good agents file, conserve context, give the agents a browser, and then parallelize. So use them for everything. I think Claude is the closest thing we have to AGI. So for example, I was buying a house. I got a disclosure packet. It's like 50 PDFs. If you try to drag them into ChatGPT or Claude, they just don't. It's a max of like 5 PDFs. But we're developers. We can just open up a terminal, open Claude Code, say read through each one of these PDFs, spot any red flags. You can vibe code convenience tools. For example, I want to ask the same question to all frontier models, GPT-5, Claude, Gemini 2.5 Pro, Grok, and I just did it in like 30 minutes with Codex, actually. You can debug your shell environment, like something's not running. You can just be like, why is it not running? It can run env, it can look at your environments, it can look at your bash RC, it can try to fix it. You can open it up in a directory with a bunch of logs. You can say, hey, like, why is my app slow, or whatever it is. And of course, they can help us work on our apps. I think the key for that is a good agents.md file, aka Claude.md file, or cursor rules file, or whatever it is. Agents is kind of what the field is standardizing on. AMP and Codex and Gemini all support it. Claude, I think, will at some point soon. And what you should write in that file is basically what you'd want a junior developer on your team to know on their first day. And also, they don't have memory. So whatever you want them, to remember in the future about the way you like to do things, you have to add it to that file, or you'll just have to keep explaining the same thing over and over again. So we can walk through ours real quick. And basically, first I set the context, like this is a Rails 8 app. We use Tailwind, we use Slim, we use Flex. Shout out Flex. You can tag in other files, like I say, read more about business logic and add README. That actually pulls in the contents of README right into there. And so that's a way to kind of modularize your Claude.md. And then I already have the app running, right, when I'm developing. So I just let the agent know, you don't need to run bin Rails server, because that's not going to work anyway. Just, it's already running, and I'm going to explain how you actually use it a little bit later. We use dip, thanks Evil Martians for dip, to manage our Docker Compose setup. So it's not going to be bundle add gem. It has to be dip bundle add to use the proper environment. So we just explain stuff that might be counterintuitive. And for Rails, the migrations are maybe a little bit not something that's seen a lot. So just to make sure we mention it. And any changes they make, we'll just hot reload, unless it's in the config directory. So we just explain that, in which case they'll need to restart. So we use linters. So we explain how to run the linters, right? Our developers are set up. Every time you save a file, it automatically runs the linters. The coding agent needs the same kind of functionality. You can use Claude hooks for this, but I actually think it's better to just tell it to do it, because if it runs the hook, then it might get confused because the file was edited. So it doesn't edit to a file. Then the hook formats the file, and now when it tries to edit the file further, it's like, oh, it's not what I expected to see. So it has to read the file again, then edit it again. So it just slows things down. We explain how to test. Now, here's an important thing. We say always use a sub-agent to run tests and report any failures. So that's important because if something's in the main thread of the agent, like all your test failures, that's going to pollute your context for the rest of the session. But if Claude uses a sub-agent to run the tests, then that's only going to be in the context of the sub-agent. And then the sub-agent can basically say, hey, this one test failed, and only expose that failure instead of all the logs. We explain how to do debugging. So you can tail development.log. If you're using the player at MCP, I'll talk about in a second, you can use the special MCP tool. And you can run code in the Rails console by doing dip Rails runner with either code or a script. And then we talk about our patterns. And there's actually a lot more than this. But basically just like, what do you want a junior dev to know about the way you like to structure things? So you would explain the command pattern to them. And that might go for like a few pages, right? And I think it's useful to do because then it doesn't read all these files right away, but at least it knows where to look if it has a question. We link to the docs it wants to, or it might find useful, just so that it has the up-to-date version. And we also add them as like allowed commands in our settings.json. And then we say, there's no API for the app you're working on. You can only interact with it with the browser. So you can use the playwright MCP, and what URL is it running on? Run this command bin echo app URL to see. And that's going to be important because sometimes it's running in a cloud environment. Sometimes it's running locally. All the devs have different kind of local URLs. And so why would you give the agent a browser? Let me see this. All right, the full screen button isn't working, but basically, you can tell Claude, if you use the player at MCP, you can tell Claude to go to your website, log in, click around, fill out forms. It all works. It's actually pretty smart. It uses a sub-agent to do it, and so it doesn't pollute your context with a bunch of like playwright script, logs or anything like that. I think it's been pretty useful for us to just say, if you're making a UX-facing change, just make sure to go to the browser and like test it and like see if it looks the way you think. Aside on MCP versus CLI, MCP is not magic, right? It's just tool descriptions and executors, as we saw. But you can't control how the tools are described. You can't control what the tools output into the context. And you can't really customize them. So I think it's better to use CLI tools, because Claude Code is already in the CLI. So it has tools, right? It has curl. It has all the things, it has a bunch of things. It can write its own tools. And then you can make them composable. You can pipe the output of curl into sed. You can do whatever you want. A tip is to conserve context. So I already kind of covered that. So yeah, we encourage sub-agent use like many times in the Claude.md. And I think by the time you get to the context length like needing to be compacted, you've basically lost. And I personally just shut down Claude and open a new one, because I think it just really suffers once. I mean, in general, it suffers the longer the context length gets, but after it compacts it, I don't know. And then parallelize across tasks, right? Like, if you get good at using Claude, you'll want to use Claude 2 at the same time, working on this task and then like fixing this bug. And that totally makes sense. And then this is a little bit more counterintuitive, but actually we found that multiple attempts per task is very helpful as well. And the reason for that is because AI agents are somewhat like slot machines. It's like, you might use Opus, the smartest model, give it a pretty simple thing, and like 20% of the time, it'll just go off the rails and like not actually do it. And then, a very complicated thing, maybe 80% of the time goes off the rails, but 20% of the time it nails it. And so if you launch, 5 of them, hopefully one of them actually nails it. If you try to manage this locally, that's how we kind of got to building Superconductor. We tried doing this in work trees and having a bunch of terminals open, but it's just too much. It's like you got to remember what you're working on in this tree, and which browser corresponds to that tree, and which terminal corresponds to that tree, and so on. And so, it just gets to be, some people enjoy it. I have a child. I can't handle it anymore. So background agents to the rescue, right? So we have OpenAI Codex was kind of the first one. Then Google Jules came out. GitHub Agent now has one. Cursor background agents now. This is like you write a task, you launch an agent in the cloud on it. Why didn't we use that? Because there wasn't one, and there still isn't, that supports Claude Code, which we thought was best. There still isn't one that supports a live app preview. What I mean by that is every agent thread should basically have a running, like it already has a running app. It's able to use it. I should be able to just go to a URL and see its work and just have that for every single agent that's running. And then our Rails app is based on Docker Compose. It has like a Postgres, Minio, Rails, and so nothing was really supporting kind of our setup. So we built superconductor.dev. I'll actually, I think, show you a quick demo if you don't mind. So here we have a project. These are like all the tickets that we've submitted. There's a bunch more that are completed, but these are like the active ones. And a simple ticket was like, we have this project setup form right here, and this danger zone just doesn't look very friendly. So the ticket was just, can you make the danger zone a little bit simpler? It's like a little too big. We can launch like a few sonnets, a few opuses on it. I'll just launch 2 more. And they will work. Now these ones already worked, and you get the chat view in this left column. You can see the log of all the actions it did. Like while it's working, it'll just show you that, and then after it's done, it'll show you that in the work log. Because it has Playwright, it's able to take screenshots. So it says like, okay, here's what I did. This is what it looked like before. And this is what it looks like after. It has this collapsible thing. And then here's what it looks like expanded. And then if you like it, you can also look at the preview. It loads up into here, and then it also, you can pop it out into its own little window. And you can look in the diff. If you have some comments on the diff, you can say, you can comment on the diff. You can log into this and use it. We have a mobile app where you can actually, start it on desktop, then as you're walking home or whatever, check, if it has a question for you, can answer it right on the phone. You can use the app on the phone. And then when you're happy with it, you can submit a PR. So I go to this next implementation, and if I'm happy with it, I can submit a PR for it. Switch back to my presentation. Yeah, and that's it. I post on Twitter. We're looking for, we're well-funded. We're looking for experienced Rails devs. If you're interested, or if you just want to get onboarded onto Superconductor, please feel free to email me at sergey@superconductor.dev. And thank you. Let's just do questions, after this thing. So thank you.
All right, awesome. All right, this concludes our programming today. Again, huge shout out to everybody for coming. Please join our Slack if you haven't joined yet. You can find the link on sfruby.com in the footer. There's a sfruby Slack. So please join it, and I'll see you next time. The update on the next time is going to be on Luma. So I'll invite you all. Again, thank you.